Hi everyone, I am Bipin Kumar, founder of RPM Tutorials. Welcome to my channel. Today I am going to talk about simultaneous linear equations in two variables. Suppose you are given this problem that solve 2x plus y equal to 5 and 3x plus 2y equal to 8. Now you are seeing here that there are two variables involved, x and y. In this equation also, this x and y. The power of x is 1, the power of y is also 1 in both the equations. And therefore it is called linear equation. Why it is simultaneous? Because you have to find a solution of x and y which simultaneously satisfies both these equations. And that is the reason it is called simultaneous linear equation. Now, there are three ways simultaneous linear equations in two variables can be solved. One is substitution method, another is elimination method, and third is cross multiplication method. Let's look at these one by one. Let's try first the substitution method. So in substitution method, what you need to do is, you need to convert one variable in terms of another in one equation and then use that transformation of variable into another equation. All these methods operate on that idea that you can have a solution of one variable if you have one equation in that variable only. And let me explain that, what it means. So let's try with substitution method. 2x plus y equal to 5. So I'll try converting x in terms of y. You can do y in terms of x also. Okay. Let's try this. So if I convert this from equation 1, 2x plus y is equal to 5, and therefore 2x will be equal to 5 minus y, or I can write x is equal to half of 5 minus y. Okay, so that I got x in terms of y. Now use that is in equation 2. Now if I use x in equation 2 in terms of y, then I'll have to write 3 multiplied by half. Of course, I need to put a curly bracket here. Half multiplied by 5 minus y. I simply replaced x from half 5 minus y in this equation 2. Plus 2y is equal to 8. And then when I solve it, I can get this as 3 by 2 into 5 minus y plus 2y is equal to 8. Which I take it forward further, then I can write it as 15 by 2 minus 3 by 2y plus 2y is equal to 8. And then if I keep y on the left side, then I can write this as minus 3 by 2y plus 2y is equal to 8 minus 15 by 2. And then I can write this further as, let's take the LCM. So this is minus 3y and this is plus 4y is equal to, let's take LCM again, it will be 16 minus 15, and therefore this becomes equal to y upon 2, and this is 1 upon 2. 2 and 2 cancels, so y becomes equal to 1. Okay, so we got the value of y as y equal to 1. Now, to get the value of x, we can put this y equal to 1 in any of these equations. Let us put in equation 1 again. We will put 2x plus y, and y we have got equal to 1. So this becomes equal to 5, which leads to 2x is equal to 5 minus 1, that is 4, which leads to x equal to 2. So we have got the solution as x equal to 2 and y equal to 1. You notice this, that when you are substituting x, you are getting x in terms of y and then substituting in equation 2. Ultimately, you are getting this equation in terms of only y. Okay, so there is one variable and one equation, and therefore you are able to solve and you are able to get y equal to 1. Once you have got y equal to 1, then you just put back in any of these equations, not necessarily in equation 1, and you will be getting the value of x. So this is the method of substitution. Why substitution? Because you have converted x in terms of y and you have substituted x in another equation, and therefore it is substitution. So this is one way of solving the simultaneous equation. Let's try another way. And that is elimination method. So here in elimination method, the idea is that eliminate one of these variables, okay, so that again the resulting equation is only in terms of one variable, and then you will be able to solve that particular variable value you will be able to get, and using that you can get the variable value of another one. Okay, let's try that elimination method. So in this method, what we do, we look at, suppose we want to eliminate x, then we will look at the coefficient of x in both the equations, and we will multiply first equation with the coefficient of x in the second equation, and we will multiply second equation with the coefficient of x in the first equation. So here, if I have to do the elimination method, I will have to multiply 3 into equation 1, and because these are plus plus sign, so I'll do minus of 2 into equation 2. If we do that, let's see what happens. I'm multiplying 3 in equation 1. So this becomes 6x, this becomes 3y, and this becomes 15, because I have multiplied throughout the equation. So 6x plus 3y equal to 15. And the second equation I am multiplying by 2, so this also becomes 6x plus 4y now, and again the multiplication of 2 and 8, so that will be 16. Now if I take the subtraction of this, so I'll have to change the signs here. Now 6x and 6x cancels, so this becomes minus y is equal to minus 1, and therefore y is equal to 1, which is again the same value which we are getting, the value of y. And now if I have to get the value of x, then I'll use equation 1 and I'll put this value of y. So from equation 1, it will be 2x plus 1 is equal to 5, which leads to again 2x is equal to 4, and therefore x is equal to 2. Okay, so we again got the same solution, x equal to 2 and y is equal to 1. So in elimination, what we are doing, we are eliminating one of the variables from using these two equations. And the method for that is multiplication of the coefficients. If I want to eliminate x, then we will be using the coefficient of x, and I've explained you how do we do the multiplication. Similarly, we can eliminate y also, and then the first we will get the value in x, and then you can use the value of x and get the value of y. So this is elimination method. The third method is cross multiplication method. So in cross multiplication method, first thing is that you have to write the equation in this form, a1x plus b1y plus c1 equal to 0. So all these will come in the left side, the right side should remain only 0. Likewise, a2x plus b2y plus c2 equal to 0. So both these equations, the simultaneous equations, you have to write in this form. And then write x here and start with a variable which is not that of x. So omit the variable a1, a2, start with b1, b2. So you write b1, b2 here. The next coefficient is c1, c2, so you write c1, c2 here. Likewise, you write y here, and then because you have written now b1, b2 and c1, c2, so the next is a1, a2. So you write a1, a2 here. Next you write 1 for those coefficients which are not having variable. And then because you have used a1, a2, so use b1, b2. Now write this in terms of, in this form, x upon this lower value will be coming out of cross multiplication of these two terms. So cross multiply b1 with c2, b1 c2, minus again cross multiply b2 and c1, this will be minus b2 c1. Similarly, y divided by cross multiplication c1 a2 minus c2 a1, and that is equal to 1 upon again cross multiplication a1 b2 minus a2 b1. So this is what we will have to do. Let us try this for this equation. So what we need to do, we need to first convert this equation in this form, a1x plus b1y plus c1 equal to 0. Likewise, this also will get converted, minus 8 equal to 0. Now once we have done that, then I need to write x, y and 1, and then I'll have to omit this coefficient. I have to start with this coefficient, b1, b2 coefficient, right? So this will be 1, this will be 2. And then after that c1, c2 coefficient, that is minus 5 and minus 8. And then I have to use a1, a2, which is 2 and 3. And then again I'll have to repeat the b1, b2, that is 1 and 2. Okay. Now once I have done that, then I'll have to write it in this form. So I will write x upon the cross multiplication of b1 c2, that is this, that is 1 multiplied by minus 8, minus this cross multiplication, that is 2 multiplied by minus 5. Okay. Similarly, y equal to, don't get confused that it is y2, the y is separate. Okay, let me write it a bit upward so that there is no confusion. Okay. Now for y, then again I will do this cross multiplication. So that will be minus 5 multiplied by 3. And this cross multiplication, that is minus of minus 8 multiplied by 2. And this will be equal to 1 upon, now this cross multiplication, that is 2 into 2 minus 3 into 1. So I have written it in this form. Now let's elaborate it further. So I'm just writing it here because so then this will become x upon 1 into minus 8 will be minus 8, and this will be minus and minus plus, so it will be plus 10, and this part will be equal to y upon minus 5 into 3 is minus 15, and this will be minus minus plus 8 into 2, that is plus 16, and this will be equal to 2 into 2 is 4, minus 3 into 1 is minus 3, which leads to x upon 2 is equal to y upon 1 is equal to 1 upon 1. Therefore, if you take x by 2 and 1, then you can write x by 2 is equal to 1, which will lead to x is equal to 2. And you can also write y upon 1 is equal to 1, which again leads to y is equal to 1. The same set which we have got. So you are getting the solution, same solution from all three methods. It is always a good practice to check whether your solution is correct or not. Now, to get the value of x, we have used the equation 1 because we had y equal to 1, and after that we have used equation 1. So let us check it with equation 2 whether my solution is correct or not. Let's do the check from equation 2. Let's put the values. So 3 into 2, that will be my LHS, right? So that will be 3 into 2 plus 2 into y, which is 1. So the 6 plus 2, that is equal to 8, which is RHS. So it means whatever solution we have got is correct. So with these three methods, now you have the understanding how to use these three methods to solve the simultaneous linear equation in two variables. I'm sure that any kind of problem coming in simultaneous linear equations in two variables, you will be able to solve it. Thank you very much.